Hiya. Hi, everyone. Hi, Kevin.
Hey everyone, hey Nick, how's things?
Uh, all good. Bit hot here in England. So,
Yeah, same here. Back
yeah.
over in Ireland, it's
So,
roasting, as we'd say here. Really hot.
yeah. So, hope everyone's keeping warm or chill. So, this evening we have another episode. So, we're going to have a theme called sustainability and security. So, we have two amazing speakers. So, before we start, we're going to do some intro. Leo is having some technical issues, so we can just wait for his to reboot his computer, and then we just get started. Uh, so let me just go through the slides and quickly. Okay. Yeah, so meet the team. I'm Nicholas Chang. I'm Microsoft MVP and Senior Platform Engineer working for Canis.
And I'm Kevin Green, and I'm an Azure MVP working for Presidio. So,
Oh, yeah.
Nick, your screen, I don't know if you're sharing the right screen, but I can see your share if you like. So, if you want to bring up the slides?
Shirt.
Technology, huh?
Entire screen, this one. Okay.
Yeah, that's better.
Can you see now?
Yep, perfect.
Okay. So before we got started, all members of this group should be abide with code of conduct, be friendly and welcome to everyone, be patient, be thoughtful, be respectful and inclusive, be open and curious, and always try to ask questions to understand something and not to criticize each other. You can do this one.
Yeah, so as Nick said, we've got two more really great speakers coming up for you guys tonight. So we've got Leo Visser, who's a senior tech consultant at OGD and also Microsoft MVP. And Leo's going to do a session on making your automations more sustainable. Then we've got Bhuvi Vatsi, who's a senior PM in security at Microsoft. Bhuvi's going to do a session on security of agentic workflows. So I see you've got the next episode there. Do you want to talk about the next one, Nick?
Yeah, so the next episode is scheduled for 10th of August, and it's with two fellow MVPs. So one new one called Anyad Royal, and he's a lead Azure platform engineer, and Andreas Lidi is a director at Software, and he's an Azure MVP. So 10th of August. So let's just see whether Leo's back on. Oh yeah. So how's everyone week been? So we can just chill for a bit while Leo's back in.
Yeah.
How's the week been, Kevin?
Hot.
A bit warm. Yeah, we got a fan as well. Trying to keep warm with lots of things. Actually, I just the company. Don't put Visio now. Visio, the parent one.
Yeah.
Next.
Yeah. All new things happening here. All right. Busy.
Yeah.
Do you want to start with Bhuvi? Bhuvi's ready to go. And
okay, sure.
Bhuvi has a shorter session anyway. So Bhuvi, can you hear us okay?
Yes, I can hear you guys okay. Bear with me. I'm just suffering from some cold and cough, so I might sneeze or cough.
No worries.
But thank you so much for having me. Am I good to go, Nick and Kevin?
Yeah. Do you want to just introduce your session, like what you're going to talk about first?
Sure. Yeah, so I'm Bhuvi Vatse. I'm the Senior Product Manager at Microsoft Security. And in this session, I would like to talk about how I have been using some of the agentic capabilities, building own workflows, and what I have learned from them. This is more of my personal learning. Yeah. And then I will also sprinkle in some security context in it. So that's what I would like the session flow to be. I have some slides prepared for this session. So Nick, let me know if I am good to start sharing.
Yeah, you can just share. I'll let you know what to see it.
Okay, awesome. I'm trying a couple of new things here, so bear with me.
Yeah, because you moved to a new team, security.
Yeah, can you guys see my screen?
Not yet.
Oh,
Just
not
if you share the desktop, it should be able to bring it up.
okay. Yeah, it's asking me what exactly I want to share, so that's a good thing. Okay, how is it now?
Yeah, got it.
Yep, all good.
Yeah, you might have to zoom in because it's so everyone
Yeah,
can see.
1 second. Let me try something. Okay, you guys can see. You want to zoom it? Okay, makes sense. How is this now?
Yeah, I think that's better.
Okay, awesome. And one final check. Okay, so you just see the screen on it, right? Okay,
Yep.
Yeah.
awesome.
Or
All right.
from
So
answering to acting, right?
yes, 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 yes. Okay, so in this discussion, I would like to talk about our journey through how we started with chatbots, where we were able to ask a question, get a response, kind of bi-directional, but at the same time very specific, very much contained. And then we moved on to the agentic phase where we were having more context. We were able to ask more questions and give the AI more autonomy on its own, but also making sure that it is not doing everything on its own or taking decisions that we don't want it to do. And then now we are in a phase where I would like to call it a persistent workflow, where things are more planned, more scheduled, and then they are happening in parallel even when we are sleeping. And that is what we are going to talk about, how my experience has been working with those things. We have things that now can work with our identity or use our identity, and they don't need renudging from us every time, and they can act on their own. And in all this journey, what has helped us come to this particular stage is that it is more accessible. AI is becoming more accessible than ever, and there are more tool chains or function callings that have been enabled through MCP or agent to age communication protocols. And that is making it much easier. It is also very much accessible in terms that, yes, I can port my agents or create my own agents, and then others can leverage those agents as well. And then as time progressed, now these workflows have more context so that they can operate for a long term of context. So I have been using some of these workflows where the context has been with those agents beyond a week or maybe for a month whatsoever. So that context of that ask or context of the whole workflow is something that they are able to retain and answer questions. On the next slide, I would like to cover on how exactly an agentic workflow is, or what are the components of an agentic workflow. So we definitely need the brain of the whole workflow, which is the model. Everything is based on how the model operates and what kind of reasoning does it have behind it. And then the next step is what tools are we enabling it with? Think of tools that are so think of tools as giving it hands and model as giving it brains, where tools are able you're able to give tools APIs, or the tools are able to search the internet for you or review your code base or even code for you, things of that nature. Then we need memory. As I was talking earlier, we will cover the short-term and long-term memory continuity in future slides as well. But just a quick context, memory is something that you want it to have both short and long term so that it is not giving you answers that are not grounded in your knowledge base or the conversation or the task that you have been with it, working with it in past. And then orchestration is something very important because at some point you want some autonomy in these workflows where they can take actions based on your instructions or system instructions that you had given in your intent to using this workflow. And how much autonomy do you want it to have is something that you have to set it up. So, end to end, what you want is the model understands what your goal is and it creates the plan on your behalf. what it is going to operate, based on what context it's going to use, and in what order of operations. It can do simultaneous order of operations, working with multiple sub agents in parallel, or it can decide to orchestrate between agents. So it depends on the whole workflow and also what questions or demands that you have. So, for example, if you are creating a workflow where every morning you want a status of the stocks, how they have been performing, where what ticker icons are used, or you want some kind of a report on how was the whole Sensex doing today, or what are the common patterns. So it can do all of that, but then it needs to orchestrate a lot of those actions and then give you kind of a summarized report. uh, it can also be grounded in your memory. So, for example, in past, have you been more interested in certain ticker symbols, then it is going to go back and refer to that so that it doesn't give you the knowledge that you have not been intending it to do or you would not prefer. And for it to do all of that, there are so many tools out there. The industry has been working on a lot of other variety of tools. So there are tools that are related to industries, there are tools that are related to certain specific technology. There are all sorts of tools available. There are even marketplaces for tools where you can go and pick the tools that you want to. And if there is any delegation needed, okay, certain agents are specialized in maybe just creating summaries of reports, or certain agents are specialized in debugging code, or certain agents are specialized just in reviewing some of the write ups. So, all of that is something. Consider an agent as a specialized unit that is working on your behalf, and then all of it is coming in parallel to make it happen, so that you are not waiting for, or you are not having to do that orchestration by yourself. And once all the results come back to you, you have the power to check, validate, and always make sure that there is no hallucination happening, which you will realize that there's always scope for that. Once you are more tweaking with these things and playing with them, you can then bring more guardrails into place and maybe tighten that piece a little bit more to make sure that next time it doesn't go off the rails, or it doesn't give you information that wasn't completely verified. So eventually, what good looks like is that you have agents that are able to research on your behalf. They can gather information from many sources. They can reconcile, make sure things are making sense. Sorry. And then give you a clean summary. And also, one thing that I always tell my agents to do is give me citations so that they're able to tell me the resources. And for every suggestion or summarized outcome, it's able to tell from what source it did bring it back on. And then things can fly on a cadence, things can be based on, hey, every 9 a.m. I want a certain kind of report, or every evening I want a dump of my whole day. That can also be something that you want to do. On the multi-step build and test cycle, it's more like you make sure that there are certain steps involved, but you don't have to hold it hand and tell it to do everything. You start more like a natural language, give the intent, and then it kind of does the whole cycle and comes back. I have personally set up kind of repeating rules where after every few iterations of a task or a particular workflow, it is going to check itself and come back and say, okay, I did make a mistake, and these are the options which I think I can take, comply on, or apply, that are going to at least give us some more confidence, or maybe more huge confidence in guaranteeing that those occurrences won't be repeated going forward. So I call them retrospective agents, where those agents have this whole task of just revising, retrospecting, finding mistakes, and then suggesting or recommending some ways to make sure that those mistakes are not repeated again. At Ignite, we did announce Microsoft Scout. Scout is kind one of the agents or the whole agentic workflow kind of agent for the autopilot series. So you will see Scout can do help you with preparing for your meeting. It can triage things for you, and it also can hop across multiple M365 applications so that it has a lot more context to work on. I will skip on this one. We did talk about context, but one thing that is very important in here, which I would like to stress upon, is that when you are giving context, it's also very important to compartmentalize the context. How I want to think about is that in my previous example, where I was talking about exchange updates, you would want to have separate work streams and separate maybe places where you want the information to be stored because at the end of the day you don't want it to run loose on all of your folders. You want it to be only taking content or accessing certain parts of your data and memory. So it's very important for it to have a persona, for it to have a clean boundary, and then for it to have a clear sense of what are the places I can go, what are the places I cannot go. So you can create markdown files where you have laid it all down and said, hey, these are the things that you can do. This is what your identity is. This is what your purpose is. And this is how you help me. And then you can create certain subfolders or however you might want to organize it, just to make sure that there is a clear demarcation of roles and responsibilities, because every agent, as I said before, is a specialized unit on its own. So it's very important to keep it clear, not muddy it, and then also making sure that they have only the context or only the paths that it needs. Okay, let's dive a little bit deeper on short-term memory or long-term memory. I did talk a little bit about, yes, we need both, but what exactly are these both kind of memories doing for us? So your short-term memory, as the word suggests, is something that you are currently working with it on, but you don't want it to be your forever memory. So if I have an ad hoc task now, I just want, let's say, I want to go to post meeting or the post session. I want to go back to this session and figure out what are the places that I needed to give more content or I needed to talk a little bit more, and I want my agent to give me more suggestions on how I can improve. Then that's just an ad hoc task and I don't want it to remember it forever. So that's just my short term memory. Hey, go to this particular place, get a dump of my talk, and then let me, what are the places I can focus more on in my future talks. Long term memory is something that I have it doing. I have the request coming for a very frequent basis, or there are reasons why I wanted to store it for a much longer term. And the other reason that I wanted to have long term memory is that because it learns from its own experiences and it gets better. So, how do you want to save your long term memory? There are many ways to do it. You can get some external long term memory, or you can get any internal long term memory options as well. But the main idea is that with long term memory, if you think of a spectrum, you're making your workflows more autonomous because now you don't have to remind them of your behavior, of or your practices, of or the recurring tasks on a daily basis. All right. But with all this with all this agentic workflows, I think one thing is extremely important, that security is going to be top of mind for lot of or almost every organization, because these things are autonomous, as we have been discussing since the beginning of this session, and these things run with your identity. So when they're operating on my behalf, so they can inherit my credentials, my files, and there won't be any way for people to find out whether this was actual Bhuvi doing something or was it some of agents doing it on her behalf. So that is a big risk surface, because if, let's say, I'm not putting the right guardrails and I have given it access to certain folders and I say, hey, go ahead and go ahead and just delete the files in this folder with extension .xlsx. It's going to do it because you never said don't perform certain actions on my behalf. So that's why securing it, making it more aware of the context, and at the same time putting those guardrails comes extremely important. One thing to remember is, and very important thing is, these things want to make it work for you. So if you say delete, they will try a lot of permutation combinations to make those things happen. So they are very perseverant in that regard. And that is why it's good, because if you ask for something, there are high chance that it'll get it done. But then you also want to make sure that there is a point at which it's like, nope, I can do this because I was told that I cannot cross that barrier or cross that boundary and do certain actions. There are a lot of agents that will be running in background that you won't be able to see. That's why this whole architecture of an orchestrator and sub agents comes into picture, because you might be talking to just one agent, but in the background they'll be spawning multiple other sub agents. So don't think of, hey, I can only see this urgent agent, so this is the only one I'm talking to. The workflow requires so many agents, tools, memory coming together. So another risk surface is you can't see them, doesn't mean they don't exist, doesn't mean they're not using your identity, your credentials to act on your behalf. So if they end up creating files with, let's say, a certain data label that was not supposed to happen, and then let's say a very confidential file becomes generic, then that's a big problem, because now a lot of the information can get leaked, and it can keep replicating its own mistakes because they never told you, the agents never came back to tell you that, hey, I created this with that particular sensitivity label, or it will just create document every time you ask it to with the same mistake. So it's very important to make sure that those bad inputs or configs are also kept in check. So then how do we make sure that all of this security is from the ground up and we are not keeping it as an afterthought? So Microsoft Security in total has a lot of different specialized products that are going to give you that option. The first one you want to think about is starting with giving these agents identity, so that we can track them, we can find their moves, we can stop them if they're doing something they're not supposed to. We can also have certain controls on data labeling, making sure that there is sensitivity attached to the right level of sensitivity attached to our documents and our artifacts. So that is what we can get it through Purview. And then we have Defender and Sentinel, who are more around, hey, things are going to happening at the security SOC layer, which is the operations layer, and we want to make sure that the agents are being tracked, but at the same time, we are getting alerts, and all these agent trails and signals are rolling into our system so that we can find out, okay, where in this workflow there is a probable risk. So it could be a post breach, a remediation fix, or it could be a pre breach kind of thing where we just find holes in the system and make sure that we are not breaking the workflow, but at the same time protecting the workflow so that there are enough places for it to be there are alert mechanisms, but at the same time we're not stopping things to be agentic. So, in nutshell, I want to quickly summarize my session. There are a couple of things that we have learned so far. One being that these lessons that I have found out are definitely my own. Uh, One is, think of in system languages, not in tasks. What I mean by that is, if you have tasks that you have been asking your agents or your workflows to perform, it's good to note them down. That's what I do. I always note down my agents or workflows that I'm creating, and then I watch them. Is this something that is a one off? Is this something that I'm repeatedly asking it to do? it's going to make mistakes. So be ready to probe them for it, because they will sound very confident at times, and it will be very hard for you to dig in and not and just believe blindly. So you might want to ask, hey, can you tell me what was the source of this information? Or hey, can you tell me for this, why did you take certain action? So that's something that you should be ready, never over trust, because there have been instances where for me personally, where the information that was brought back to me looked very solid, but at the same time it looked a little bit too good to be true. So I went ahead and probed it, and then it came back saying that yeah, it did make a mistake. If at any point you feel like, okay, I don't know how to fix this. For example, in my case, I'm not a software engineer, I'm a product manager currently. So that means that there are a lot of technical nuances, because I want to code to, or I want to create prototypes, and I don't know all the technical nuances. So I'm like reverse prompting and then asking it, hey, how would you take this certain action? Or if something is blocked, then I would ask itself that, hey, can you ask me on how to fix it? And then it start giving you ideas, and from those ideas you can take your next step. So one thing I love about this whole workflow system is that you can take its help to move forward, but also you can take its help to remove any blockers at the same time. It's just a matter of asking. But since I've been creating a lot of these workflows, I end up taking a lot of tokens too, burning a lot of them. And then at some point, I'm like, okay, so then I need to think about token efficiency to make sure that I'm using them, but also using them efficiently. So then the idea of whole token maxing changes to tokenomics, because you want to make sure that you're using them in a more sustainable, efficient way. How do I do that? I actually look at my own patterns, like how I look at my tasks. I look at my own patterns to see what are the things that I ask it very frequently, and maybe it makes sense to for me to create some schedule out of it. Or I ask it back that, hey, what are the main things that you and I end up burning a lot of tokens on, and how can we make it more efficient? Again, reverse prompting comes into picture, and then it helps us create that kind of leverage. And if you feel like, hey, in my current work, I feel like I don't know what use cases I can leverage it for, I have a strong opinion that we all have use cases, not just in daily life, but even whatever you might be doing or whatever your nature of work would be. There are multiple use cases that you can use AI for. Like for myself, I have use cases at work, out of work, for my hobbies, for my own personal schedule, for my other activities. And then building again the whole mindset of not building tasks but building systems out of it. And then somebody in a couple of weeks back asked me that, hey, could you tell us some skills that are really necessary going forward? um, and suddenly I was like, oh, you need to learn about how to be a good manager. And the reason I say that is because at one point i I end up managing so many agents, and I'm continuously managing them. If I'm not efficient at that, if I'm not managing them well, then there are a lot of security risks that can happen. There are a lot of delegation risks that can happen. And then there's a lot of time wastage that happens in fine tuning them or stopping and closing and things of that nature. So if there's one skill, or there are so many other skills we can talk in maybe in a separate session, but for this one I'll just keep that as our top skill, to think about how to be a good agent manager and have fun. That's what I would conclude it with, because we are in here for fun. We experiment, we bring our curiosity in, and we try to make workflows that are not just making us efficient in our work, but also as a well-rounded person. For example, if I want to learn a skill that I'm not good at, I would go back to my skill agent and say, hey, I want to learn this. Maybe you create make it more interactive and fun for me. And then we go back and forth a little bit, and there we have something that I can enjoy more while learning at the same time. So that's the whole experience altogether. Let me know if there are any questions, but that's it. Thank you.
Uvi, thank you very much. That was really interesting, and it aligns with a number of conversations that we've been having with some of our customers over the last few months, especially around tokenomics and, hey, we've got these AI models and they do all this cool stuff for us, and we can run this model or this agent workflow to create this and save us a bunch of time. But then behind the scenes, that's racking up costs or it's racking up compute. And your concept of, we're all becoming managers of agents that we didn't hire, but you still got to manage them. I really like that too. So I think that session is something that's going to become more and more relevant to people as they start using AI in anger versus just dipping their toe and, or somebody just using it as a Google replacement. When you start using it for proper agentic workflows, that's when you need to be smart about it as well, because there's no infinite pot. We all know that there's capacity issues in all of the global hyperscaler data centers. And when there's capacity issues, there has to be economics behind the charging and the cost of those AI models, not just with Microsoft. So organizations and end users are going to have to manage that as well. So yeah, really good. I like that session. Well done. I don't see any questions. We did check with the audience just to see if anyone have any questions on it. I don't see any on the channels that I'm in. Nick and there's Leo back in action as well. Any questions from you guys?
No, sorry.
No.
I missed half of the talk due to technical difficulties.
That's all right, Leo. That's okay. Uvi, I think we can let you go. I know you're feeling under the weather as well, and you don't need to hang on here for us and listen to us talk more tech when you probably just want to go to bed and relax now at this point. So
Thank you.
I would say thank you so much for coming on, and thank you very much for your presentation. And
thanks.
We'd love to
Thanks
have you
for coming. No worries.
Thanks for going first to cover me.
No worries.
Well, Leo, last but not least. So
did you know why he had an issue? He had like few different like buttons in his Windows that meet all the mic. So I was shocked.
So today I learned that you've got like the normal volume manager. Then if you go in the advanced settings there's like more volume buttons. And then inside there's even more ones. And if those are set to mute, all the others doesn't show that it muted. So everywhere it shows that the mic was working, but the mic was muted. And apparently all my mics, I have 3 different mics, and all of them were set to mute in this hidden setting for some reason. I think either somebody pulled a prank on me or some update didn't like microphones.
Yeah, the tech gods and the demo gods are out to get you, Leo.
Yes, well, it's fixed, and now we can talk a little bit about how to make sure that the tech is not going to ruin the whole world.
Well, Leo, the stage is yours, buddy. Go ahead. Make sure you can share, and you can kick off whenever you're ready.
I believe you should be seeing my screen now. If you are setting it on the screen, yes.
Yeah.
Okay.
All good.
Great. Then let's start. I hope the audio levels are okay. I haven't had time to check this.
That's good.
Okay. Then welcome to my talk of making your automations more sustainable. I will be going through this quickly because I've got a lot to tell about this topic and not a lot of time. So I'm Leo Visser. I'm a consultant for cloud and AI. You can find me on the socials and my blog and my LinkedIn. If you want to talk sustainability, if you want to talk automation, if you want to talk AI and how to control AI more, please connect. I like to talk about this stuff. Sorry, that was a slide from a previous event. I thought it was hidden. So we're going to talk today about a couple of things. What is sustainability? We're going to talk a little bit about shared infrastructure, a little bit about how you can improve your code, some data sources you can use, how you can actually use these data sources to improve Azure automation, and some future goals, which I hope you might be able to help me with. So, like this picture says, I think you can see my mouse. Yeah. I don't have a full solution yet. I offer help. I want help, and I just offer ideas here. Because sustainability, it's more than just having less emissions. Sustainability is a lot of different things. The United Nations has 17 different goals for sustainability, which are listed here on the screen. You can find this also via URL. And I might be able to post some of the URLs later under the YouTube link or under the YouTube video if I don't forget. If I ever forget, feel free to tag me and I will post them later because it's sometimes hard to type them over from recording. And a lot of sustainability is about looking for opportunities. We want to look in our companies, in our lives, in our societies for ways how we can improve the different goals and how we can go there. And there's still a long journey ahead. If we're looking at sustainability, we could look at like the climate impact by emissions, and IT has a quite significant factor in this. There's, especially now with the whole AI boom, the data centers are using quite some energy. A lot of people are also still saying a lot of data centers are using a lot of water, which, as far as I know, is getting a lot less with the new cooling techniques, which don't really use so much new water. But that's still up in the air if this will really be applied to all of them. And it's often hard to sell to corporate if you want to start doing more with sustainability. Now, there is one thing which can really help you, and that's the Corporate Sustainability Reporting Directive, the CSRD. And this directive, it says that several types of companies, they have to report about their sustainability and about their emissions and so on. Depending on how big you are, what kind of area you're in, you are either already in this directive or will be eventually. So if you've never heard about it and you want to convince corporate about doing more about sustainability, look it up. If you're somewhere in the European Economic Zone, at least, it's probably going to affect you quite soon and you want to look into it. Now, there's also the thing about carbon offsets. I think that Kevin and Nick, who are here, have at least sometimes booked a flight and seen like this nice checkbox when you're booking a flight that you can pay a little bit more to make your flight greener. And that doesn't mean that they pay the airplane green, unless you're flying Transavia, but that's something different. So with carbon offsets, you can kind of buy tickets from companies who are carbon negative or initiatives who are carbon negative. So say you are buying up pieces of forest. So these forests are not cut down, but they can absorb more carbon from the air. You can sell this carbon negativity to other companies and make more money with it. So this is what companies are doing. And it is a market. So the more cheap you can get these carbon offsets on the market, the more companies will buy it from you. So you will see companies who are doing sometimes creative accounting to still be carbon negative. Like, for example, buying up nature reserves, because then the nature reserve won't be cut down and therefore you can sell these negative carbon emissions, which personally I think doesn't really work, but it is still something which is being looked into and it does help in certain situations. Now, if we want to look more at IT and what we can do, there's often one thing I talk about with my customers first, and it's about talking about shared infrastructure. Because if you are having a machine to run, say, scripts, ETL pipelines, maybe AI workloads or whatever, you will often have your machine not run at full tilt all the time, especially if your machines have to be ready to also work in peak situations. Your machines are often not running at full percentage. And what you see here on the screen is over time, they've taken a CPU and slowly, which is the red line, decreased the utilization of the CPU with a benchmarking tool, something like Prime 95 or so on. And in this way, we can see that the wattage which is being used, which is the blue line, it is also going down. It's in a less steep curve. And what we can actually see is that even when the CPU is utilized at 0%, the wattage is still above 250 watts, while it started at 425 or so. So a better overview is this graph, where we can actually see the energy efficiency compared to the utilization. And because the power is only going up slightly, the more utilized our machines is, the more energy efficient they are. Because at 0%, they're wasting a lot of energy. And a lot of the machines we are setting up, they are working in this 15 to 55% operating window. I mean, some of you might have set up scaling systems as your virtual machine scale sets, for example, and you've done this by CPU percentage scaling. You don't start scaling your machine set when the CPU is at like 100%. You do this when they are at like an average of 70% or so, and then you're adding new machines already, which means that typically they will be in this area. And they're actually wasting quite some energy because they're not so running so efficiently. If we're using less energy or less servers to do more, we can have these servers run on a higher utilization. And if we take more loads together and put them all on these machines and use some orchestration to make sure that they all have enough room, we can use less energy. And this is where the shared infrastructure comes to play. If you're using services like Azure Automation or a Microsoft hosted agent to deploy stuff in Azure DevOps or in GitHub, these machines, they are hosted by these hyperscalers, and they are set up in a way that they will try to do as many jobs as possible with the resources they have, because Microsoft doesn't want to waste money, and every utilization which is not being utilized wastes money because they do have to pay for these machines. So this is why I would often advertise to use shared infrastructure. Shared infrastructure, it is also nice if you look at stuff like storage, because if you want to look at storage in a emissions way, in an energy use way, they are actually using burst patterns. So if you have storage, a lot of us, we think that the storage is just there and only when it's written to or read from, it will use energy. But actually nowadays with NVMe drives and so on, it will also at different times create bursts. For example, when doing garbage collection and other stuff. Older hard disks, they have more of this system where it's only when you're reading and writing to it, they use energy. But with more modern storage techniques, this is not the case. And this is something to keep in mind also when you're having your own systems. And especially network is always one which I find very difficult to wrap my head around when I first think about this. Because if you follow the website, which is linked here, it will bring you to a research paper where it shows that if you're sending more data over the network doesn't really use more energy. You've got some more energy usage on the machine for using the network stack and so on. But the network infrastructure itself, it's kind of running on full tilt all the time already. And only when network use gets so high that new machines have to be added, the energy will go up. So it's like a really big staircase kind of graph, where only with a lot of new data being sent over, it will use more energy. Now we can also look at our code to make our code more sustainable. And here I've got a couple of scripts, and I'm going to go over this a little bit quicker because I don't know how many of you are really programmers and so on. As you see, I'm not a programmer. I'm just using some PowerShell, and real programmers say PowerShell is not a programming language. But just some things to keep in mind when making scripts for automation or whatever. Here, for example, I've got the numbers between 1 and 100, and I'm looking for number 42. And I'm looping through the numbers, and when I found it, I set the found variable to true, and then I say I found it or not. This is a script which I've seen in practice when checking mailboxes or stuff like this. But if we make the script like this, where we just say once the number is found, we actually stop running the script. In case of 42, there's 58 cycles we don't go through. And only if we've been to all of them, we can say it's not found. There's actually mechanisms to make it even better, but this is just something to keep in mind. Same with APIs. If I want to get several different users, for example, from an API, and I'm calling them all after another, I could also use like a version where I just call like the top 5 of them, get them all, and then store them in memory and print out the values I need to print. This way I only have one API call, because these API calls, although network doesn't add much more energy, my system to send a network request has to do a lot of different stuff. So if I only have to send this network request once, it's nice. Also, it could mean that the machine is actually waiting if it's like a really parallel or a really serial processed machine and not really doing anything else in the meantime. The last one is, say I've got to get like different users once in a while. Some ones might be double in there. I could just look up every user all the time and print their information. Or what I can do is I can create a cache. And in my machine, when I'm looking something up, I just cache it locally. And when it asks again, I can just say, oh, I've got it in cache already. You do want to have some kind of duration in there. So eventually it will look back up the information again, depending on how static the information is. I've done a little test with this where I've used tracer, which is a PowerShell command that you can use to check how fast something was running. And if you're looking at the execution time in seconds, for example, this is not a perfect measure to see how much energy it really wasted and how much cycles were being used and so on. But it is something you can use kind of to get an indication. And here, for example, we see that loop 1 normally took like 25 seconds, and in a fixed version only took like 1.5 seconds. And you see that every time it's down. So when we're talking about code, it is important to also look at the CPU cycles we're spending, making sure that we are making automations, that we're making code which doesn't use too much cycles, and we don't have stuff just running there doing nothing. That's wasting a lot of resources, and especially on shared infrastructure, these resources could be used by other people. So let's go into some data sources. Here on screen, I've got a couple of data sources. I will try to link them all, and I'm quickly going to show them to you. So first one is Carbondi, the carbon data intelligence. This is a platform where you could, for example, look up company emissions. And if we look for a favorite company, we can see that there's been several disclosures. These disclosures can either be by them or by people who found the disclosures and added them to the platform. This is just a place where you can find disclosures and can help people finding them. These are often self-reported, so this is not really taking anything from specific places, but this could sometimes help doing some research about stuff like data center usage and so on. The next one, a platform probably many of you know if you are using tools like Home Assistant or so on. Electricity Maps, it's a platform where you can use APIs and other tools to get energy information about several different places. It's very nice. One thing I don't really like about it is that some of the methodology is kind of obfuscated and not really transparent. Also, there's a pricing component to it. One thing I still want to mention is the Cloud Carbon Footprint Initiative. This initiative has by now been discontinued. So you can still use it, but it's not being maintained actively anymore. But it's an open source tool which you can use to connect to different cloud providers, to Azure, AWS, GCP, and see kind of your emission data. It's showing a lot of the same data as the emission dashboards from the hyperscalers themselves. But the nice one about this, I personally find, is that you can compare different kind of cloud providers with each other. One which is still quite new for me, and I still need to look into it more, is Spruce, which is kind of a continuation of the Cloud Carbon Footprint. It's not really making a dashboard anymore in the sense that you just have the dashboard which you can navigate. It's more working in pipelines which are creating the reports which you can then look at. It's using the same kind of data, and in a lot of cases the same methodologies. Most of the methodologies are all explained in the docs, going deeper and deeper and so on. And it's using a lot of different data sources to get to estimates or very good guesses about how different platforms are using emissions and what kind of emissions they're creating. One of the things Spruce is using is the Boa Vista API. Also one I still need to look into more, but it's a place where if we put it to English, we can probably read it better. A place where they try to have a lot of information about different kinds of machines, different kinds of architectures, and how, for example, different loads will affect it and what kind of emissions or energy use it's creating. These, by the way, Spruce and Boa Vista, they are both open source. If you ever want to help with this, feel free to look at them. The one I'm going to focus on today is the ENSOE. This is a place where a lot of European markets need to report their information to. And we can click, for example, here on the United Kingdom. And we can, for example, I've never done this with the United Kingdom, so let's see if this works. Do we have it from yesterday? Let's see. Let's take the Netherlands for a moment. Normally it's showing stuff, yeah. So I can, for example, ask for tomorrow for the forecast for wind and solar energy. And I can do this for many different areas, which they're all shown here. And this gives me like the forecast for yesterday. I can also look at today. And I can see the actual versus what was forecasted. And apparently they were not so good at forecasting. This could either be because there was just less use or other stuff. I could, for example, compare this with the other forecast. And I see that here, so the actual is also lower than the forecast. So probably the whole energy usage was lower than expected. Yes. So why I like the Ensoe is there is an API available. It's actually free to use. I can look for many different countries in there. Some countries are even split up in different grids. There are Postman libraries available. If you don't know Postman, it's a tool which you can use to connect to test different APIs. Some problems is it's using EYC area codes, and they're not the most user-friendly ones. So these are EYC codes, and let's just put them to all codes. Say I'm looking for the Netherlands, then this is the one I need to take because this is like all of the different functions. And this is the code I need to use. If you look at the platform, the Postman libraries, and I would go to generation, the generation forecast for wind and solar, for example, it shows here the domain, which is like this EYC code. So I would need to know the different EYC codes for the different areas. These you can look up and so on, but it is something to keep in mind and something which makes it a bit harder to get into. There is a lot of docs here about it. It first doesn't look like much, but everything you need is actually in here about different kinds of enumerators and so on. If you want to get an API key, the procedure looks very intimidating the first time because it says you need to send some email to some place with some information in it. I've done this and there's no vetting at all or whatever. You will just get an email with, here's your API code. It seems that it's not really a problem getting this API code. It's just they want to do a little bit of a check in there and didn't want to make it a completely automated system, probably for some spam prevention. Now let's go into the interesting stuff. How can we use this in Azure? So here I've created my Green PowerShell resource group. And in there, I've created a Planner Azure Automation account. In there, I've got some runbooks. And we're first going to look at the schedule runbook. What the schedule runbook does is I've got some parameters, some descriptions. This is just a function to calculate the distance, so I'm going to skip over it. These are some of the enumerators from the documentation. Like here, I've got all the different area EYC codes. And I've got some other types of codes, which are all in these enumerators. What I'm going to do is I'm going to get some variables, some API keys, and so on. I'm going to connect to Azure. I'm going to get all Azure locations. I'm going to see which Azure location fits with which EYC zone. And I can do this by the calculate distance because the Azure locations actually give me GPS coordinates. So by checking which GPS coordinate is in this location, I can define which location fits with which zone. And then apply it or see, oh, we're in this specific zone. What I want to do in this script is I'm going to retrieve the energy use for the next 24 hours, and I'm going to check how much fossil energy and how much wind and solar energy, so how much green energy will be produced. This is all what's happening here. And then I'm going to see which slot is the best, and I'm going to schedule my automations which I need to run on this best spot. So if we look at the run which has been done yesterday evening, we can see that it said, oh, we're running in West Europe. So the EYC code was the Netherlands, which is correct. And here we've got the green expected and the fossil expected. And we've got them all for all different times. And here said, found the best slot at 48 this time. So if we look at 48, this is the fossil expected, which is very low, and the green expected is higher. So it's looking at when there's the least fossil energy expected. And this is the moment I want to run my automation, because this is the moment most energy in the grid is green energy. And then it schedules my things to run. So I believe they should have run at like 9 o'clock, but this is UTC. So I think they should still start to run, but we could look at them later if we want to. Another demo I want to give to you is the other run book. This is the Move run book. Let me click the right one. Sorry. So with the Move run book, I'm kind of doing something different. A lot of the code is the same, but here I'm going to go through all different locations. And for every location, I'm going to check what is the energy use in this location. And based on this, I'm going to move my machines. I see that there's no jobs which have been run. There used to be jobs before. So I can just start one. Let me check. And I'll continue for a moment and then we check on the output. But what this does is it will go through all the different regions and decide which region has the least amount of energy use, and it will move my resources to this region. Say, for example, you've got a runner for CI/CD jobs, and at night it's not really doing anything. So at night you shut it down, and you know tomorrow at 7 o'clock or so, my developers will be back and they will need to use this machine again. And just before then, you just use this script, look at the prognosis for the next day, and move this machine to the location where it's best. Could also be with different kinds of application servers and so on. If you've got resources which don't have this big latency dependencies, it's no problem to have them in different locations. Sometimes you do have problems with either rules or whatever, or cost. And I will get back to cost in a moment. Here we see it's actually giving the green energy, the fossil energy, and a percentage. So it sees now that Switzerland has only green energy. So it says we have to move to Switzerland. And I skip the rest of the script to not do this. So what you could do is use cost as a tiebreaker mechanic, because you can also look at the cost of different automations and different regions. And especially a lot of the regions which are better for energy use are often also better for the cost. So if you can convince your corporate, like, hey, can we just, for example, take a couple of these regions, which are all very cheap, and only move in between them, or have like, if you start at West Europe and say everything cheaper than West Europe is okay, you've got quite a big range of locations you can pick from. And you could say some of the higher costing ones are not being used. Also, these costs will probably only get more variable and change quicker depending on energy cost and so on. So my future goals is, if people think stuff like this is interesting, I would like to create a PowerShell module for ENSO-A, or maybe for some of the other systems. If you think these are interesting, please let me know. And I would also still try to convince Microsoft to publish again data about their PUE and also the WE. They used to publish this, and lately they haven't been doing this. And this is the power usage efficiency and the water usage efficiency. So this shows how much of the power going into this data center is actually being used to perform jobs and perform actually workloads, because there's also power being used for lights, cooling, and so on. So they used to publish this data, but they don't really anymore. And this can really help getting your estimates even better. Also, I would like to look more into the Boa Vista API, which is about this hardware efficiency and so on. And I'm looking into maybe, instead of moving resources around, having these resources just completely shut down in regions and using more like global load balancers to direct the traffic in the right way, and have a system look at the load balancer instead and send the information there, and then from the load balancer send it to the right place. Of course, with all these things, it only depends on how big your workload is. If you have a very small workload, stuff like this is not useful, because the overhead of running this all is bigger than the gains you will have. But if you're talking about very big workloads, if you're talking about VMs which are running all day long, doing all kinds of build jobs and so on, these kinds of things can be impactful. And this is only one of the opportunities I spotted and wanted to show you about it. And maybe this will inspire you to look at different opportunities. I hope it will. And this was my talk. Thank you very much.
Very insightful, Leo. I haven't seen a presentation like that now where you're talking about ENSO-E. Well, when anyone's talking about ENSO-E and green cloud and green automation. So that's really good, really clever.
Yeah.
And probably a very hot topic as well at the moment, I guess, for a lot of organizations.
No, it's really hard still to get it on the table with customers and also at conferences. We've got some conference speakers who talk about this kind of stuff, and we often joke with each other that we're sitting at each other's sessions, and it's like we are each other's audience also, and all the other people are at the AI sessions.
Yeah, it's quite good to know about the sustainability to save energy. The Switzerland part's good, all green.
Yeah, I mean, it is in the end. We've got FinOps, and FinOps is mostly about making the systems as cost efficient as possible. And if you're following FinOps, you're also mostly following GreenOps. GreenOps is in some cases just going one step further, but it's mostly just following FinOps. So that makes it sometimes easier to convince companies like, hey, we can start going in this direction by just start introducing FinOps, and then maybe eventually we can just make these steps further, or accidentally make them without really saying it. And then it's like, yeah, it's the best choice for cost and for sustainability. And especially if you're working with government and so on. they sometimes don't really know that this is something they could do, and mentioning it at like a government IT organization or so on, especially if they can bring this up in the chain, this can really help maybe getting some budgets or getting some approval factor, because politicians like to talk about how they improved the efficiency of the IT department of this government agency and also made it more sustainable.
Yeah, we're seeing a lot of, well, quite a few government tenders coming out, when they pitch for business.
Yeah.
And there's quite a few of them now are asking for the people tendering for that business to explain what their green policy is as such, and what their energy saving and their carbon footprint policies are. And organizations who respond to those tenders who don't have a strong story might find themselves, in that space, might find themselves weighted out of the tender process, because the scoring for that specific section is getting higher and higher, particularly in government orgs. So yeah, that's again another maybe key area to consider. And it may well be only a matter of time before it becomes more prevalent and people get sick of just talking about AI, Leo, and end up coming to your sessions around this topic as well, because sustainability is definitely a topic that people are considering. This is why we're having capacity issues in a lot of the data centers, because there's energy constraints, there's sustainability worries, or governments are not sponsoring the big hyperscalers to build more and more data centers using the electricity and the grids that they currently have. They're looking for newer, greener ways of deploying those data centers, but running them with green energy as such. So
yeah, this also backfired already. I don't know how much you read about this, but there were like government agencies who started just blocking off data centers from the energy grid, and instead of not building data centers, they just build it and put like big gas turbines next to them, and just bought the fossil fuels and run their own energy turbines next to the data center to still make sure the data center could run.
Okay.
Then it's like, then we could just as well connect it to the grid and at least make sure it's using the green energy where possible. Also, with the tenders you're saying, I've seen this too. In my experience, it's still mostly about this directive, which I was talking about. And it's mostly about them wanting to be compliant to this reporting directive, and seeing parties which are actually interested in also innovating in this space and actually trying to improve it. It's still very hard. They know that they now have to report upon it, but this reporting doesn't have any implications. It's just you need to tell people what you're spending or what you're creating emission wise and so on, what you're using from third parties, but you don't really, as far as I know, have to have improvements in this. But I still hope that the EU will also eventually start doing this. I know they've done it with bigger industries, with bigger make industries, factories, and so on, to give them targets to reduce their emissions. And I can see this happening in the IT space also eventually. And if this happens, then we have an interesting conversation.
yeah, for sure.
Yeah.
And of course, we're also looking into how to make AI more sustainable. That's a different talk I
that's
have.
true.
Yeah, but that goes
Of
back
course.
to Boovy's talk earlier about tokenomics and stuff like that. Like, yes, a lot of that is on the FinOps side, but you're going to have to build in, efficiency. Maybe if you run a greener energy and a cheaper energy source to feed those tokens that are needed for those AI queries and agentic workflows, then the organizations that do that will find that it's maybe in the longer run cheaper or more economical to do it as well. Again, still very hypothetical because we're still early days, but I do think that is the type of conversations that are going to need to start springing up a little bit more as more and more people look for alternatives to the type of energy that we have now. especially the costs, because to run, I don't know about you guys, but the tax to run electricity over here in Ireland and even fuel your diesel and your petrol cars is just gone crazy. So
Yeah.
people are definitely looking for alternatives.
Yeah. With the AI systems, we still have quite big challenges with deciding where we want to run the AI systems.
Yeah.
We kind of can say we want to run them in Europe or in the States or whatever, but you can't define it as much as, for example, with a VM. With a VM, you can almost say in which data center it's running specifically in the regions and so on. With these AI systems, we can't really control this much anymore. So it's mostly now about reducing the amount of energy being used. But eventually, we hope that we can also steer this more. And then you can also look at stuff like which region would be best to run this AI system in, both latency wise and energy wise. So yeah,
It makes total sense. Cool. Well, look,
Okay.
there's no questions coming in. Yeah, I don't see any questions coming in on any of the channels. So I guess you've explained it really well. And as usual, folks know where to hit you up if they do have any queries, or maybe they don't feel comfortable posting the questions here right now. They can reach out to you directly, or they can post a question to myself and Nick, and we'll get that question and answer over to you.
yes.
It's an interesting session you did.
Yeah,
It's
very.
really cool. Yeah.
Very good. Good sessions tonight. Interesting topics.
Yes, I will be watching back the other one also later, at least the first part, which I missed.
Awesome.
Yeah, feel free.
Make sure you have your audio working next time.
Yes, the listening audio was not a problem. It was mostly the microphone.
Like, yeah.
Yeah.
Oh, okay.
I could hear you all,
Windows,
but
right?
yeah, I just couldn't get the microphone working. I was like, let's just give it a reboot. And apparently I had like a BIOS update being pending, which took
Yeah.
like 10 minutes to go. So yeah,
Always the same.
Always
we
Windows.
know we hate and love Microsoft and computers at the same time, right?
No comment.
Yeah.
Well,
Okay.
thank you very
Okay.
much for organizing this again.
No worries.
Very
Okay.
welcome.
Thanks for joining, Leo.
Thanks for coming on, Leo.
Thank you.
See you soon, guys. Have a good
Bye.
evening.
Yeah.
Bye.
Bye. Bye.